All right, guys, this video is on augmented matrices, and this is actually pretty cool stuff. And it's cool stuff because it's actually pretty easy, and and it's extremely helpful to work some of the harder problems we get into later. So let's just say that we have a problem that looks like this. So we have 3x1 plus 2x2 equals -2. And let's have 2x1 plus, well, let's switch this up. Minus x2 equals -6. Now I've messed things up a little bit here. Instead of using x's and y's, I used x1 and x2 for a reason because, excuse me, I know that sounds like it's a bear or something coming through. I'll clear my voice, but I'll clear my throat. But the reason I'm doing this is not to confuse you, but just to show you that this sometimes happens. Now, I don't really know how I want to teach this. Let me kind of think this through. The first thing that I want you to examine here is that we can break this into matrices. And using the things that we talked about earlier, we can create this as what's called a coefficient matrix. And a coefficient matrix is just the numbers that we see. Now, imagine kind of you've got a division right here. Things to the left and things to the right of the equal sign. So what we got here is I put the 3 and the 2 right here, and the 2 and the -1 down here, and I call that the coefficient matrix. What I can do next is I can come in and see that I've got this as x1, x2, and then on the right-hand side, I have -2, -6. Now, don't be confused. If I had written this like this and not parentheses, guys, excuse me. That's I don't know what happened. That's equivalent. I had a student last time saying to Dr. Darbo, why do you sometimes use parentheses and sometimes you use this form? I really don't know. It just usually when I use column vectors or column rows, I use parentheses, and so there's no rhyme or reason. Now, something we found out earlier is that in matrices that we can't. There's a community property in mathematics that says that A times B is equal to B times A for real numbers. In other words, if we take 2 times 3, we all know that that's the same thing as 3 times 2. This is not true for matrices. So the side that we multiply on becomes an issue. So I want to illustrate something to you here. If we take this 3, 2, 2, -1, I don't know if you guys can see, yeah, times x1, x2, and then over here we've got our right-hand side as -2, -6. I think in the simplest form, it's pretty clear where these numbers come from. They're just, especially this part over here, -2, -6. It's just, let me overlay the original problem here. It's just the numbers that we have, right there. But does this side over here equate to what we have over here? Well, guys, let's think it through. Right here we have a 2 by 2 matrix, right? And here we have a 2 by 1. So these two numbers right here have to be the same for us to be able to multiply those together, okay? And let me write this a little bigger. This is a 2 by 2. This is a 2 by 1. These two numbers here have to be the same, which they are. The resulting matrix we'll have 2 rows and 1 column. This is what we did in the previous matrix. So in other words, we're going to have row 1, row 2 with 1 column. Now, how do we get this entry right here? We take a linear combination of row 1, column 1. So I have tunnel vision on row 1. I have tunnel vision on column 1. Well, I take the first term times the first term, which is 3 times x1, and I add the second term times the second term, which is 2 times x2. And what you can see is that part right there matches up exactly with what we had right here is the 3x1 plus 2x2. If we do the same thing for the row 2, we take the first component 2 times x1, and the other component times the second component, negative x2, which again is exactly what we get right here. And of course this is equal to negative 2, negative 6. So guys, we get the same thing, we're just using matrices. So let's go back now, switch all that stuff, and let's come down to what we started with. 3, 2, 2, negative 1, x1, x2. Again, we're not using x's and y's. And negative 2, negative 6. Now, what I want to do is, and I'm going to get off of this page, and I want to go to something. No, I'm not. I'm going to stay on this page because it's going to be a good teaching tool. If you think about this in matrix, that's just a number. If you think about this, that's just the variable. And if you think about that, it's just a number. So this is kind of equivalent, if you can use kind of a stretch of the imagination, to a number times a variable equal a number. That's kind of what we got. In matrix world, we've got a number. Okay, it's an array of numbers, but these are unknowns, so they're the variable, just like an x would be down here. And these also are numbers, as we have in the 6. Now, if we were going to solve 3x equals 6, what would we do? You might say, well, we divide by 3. But guys, we can't divide matrices. So what would we do here? We would multiply times the multiplicative inverse. 3 to the negative 1 power. We would multiply by the multiplicative inverse of the side that I want to get rid of the 3. And I don't have to, real numbers are commutative, so I can multiply 6 times 3 to the negative 1, but I'm setting the stage to do this on the matrices, which I don't have that property of I don't have the commutative property. I can't multiply. A times B in matrices isn't always equal to B times A. In fact, it usually isn't. These things cancel, if you will, to give me x equal 2. Okay, without dividing, you can multiply by the multiplicative inverse. So gang, what that leads us to is it finally, after all the smoke clears, I'm going to leave some room to do this. I want to multiply over here times its inverse. But because if I multiply on the left side over here, I got to multiply from the left side over here. That's just the way that matrices work. I get this. Now, notice what happened up here when I multiplied by the multiplicative inverse. I just got 1. Well, guys, that's what's going to happen right here. I'm just going to get a 1. This matrix multiplied is going to give me 1, so to speak. It actually gives me 1, 0, 0, 1. But so what I end up with is x1, x2, that's the only thing left over here, is going to be equal to 3, 2, 2, negative 1, inverse, times negative 2, negative 6. Now guys, your brain is probably hurting, but that's okay. That's my goal, is to make your brain hurt. No, it's really not. Now, what am I going to get here? Well, I've got a 2 by 2, and I've got a 2 by 1, and I'm going to end up with, these things are the same, so I end up with a 2 by 1, which is exactly what I have here, which will be my solution. Now, let me show you on your calculator how to do that. So what I'd want to do is I'd want to clear all this out, and I want to go in and I want to create a matrix. Well, back here, I'm going to just create this matrix as A, and I'm going to create this matrix as B. Okay? So my matrix A needs to be a 2 by 2, so I'm going to come over to Edit. And I need a 2 by 2, which I've already got the setup there. So it needs to be a 3. That needs to be a 2. I'll worry about that inverse stuff later. And a negative 1. You're probably sitting there thinking, Dr. Darbro, this is not easier than some of the other stuff. Hold on, okay? Hold on for the ride. All right, I need to go second function quit to get out of there, just so I can go back in. And now I need to set up my matrix that goes on the right-hand side. Down here is B. But that matrix needs to be a 2 by 1. And over here we get negative 2, negative 6. Now, second function quit, so get back to a blank home screen. And guys, if you got any stuff there, you know, if you haven't maybe completed it out, you got to clear all this out, because you can't start a new command with something already there. So now, guys, what do I need? Let's go back and think about what I need to solve this problem. I need to take my A inverse times my B, don't I? Well, guys, that's really simple to do with your calculator. Go get your matrix A, call it up. You've got an inverse key right here. And multiply this by your B, so we got to go get it. Guys, the solution to this problem is negative 2, 2. Now, what does a solution tell you ultimately? At the end of the day, after all the smoke clears, what does that negative 2, 2 tell you? What's so holy about this negative 2, 2? Well, it tells us that back in the original problem, we started many moons ago, or at least it seems like it. It was only about 20 minutes. So the solution is x1 equals negative 2, and x2 is equal to positive 2. And you can think about this, if you want, as an ordered pair, negative 2, 2. This is the only ordered pair that makes both of these true. Okay? So if I take 3, x1 negative 2 plus 2 times 2, I get what? Is this negative 2? And I'll put a question mark there, so I get negative 6 plus 4. So it makes that a true statement. Let's try the other one. 2 times negative 2 minus a 2 Is that equal to negative 6? Well, over here we get negative 4 minus 2. So it makes a true statement. Guys, this is the only ordered pair that makes a true statement in both. Now, why is this, you know, you might be sitting there thinking, yeah, Dr. Darber, I could have easily have done that using the addition or the elimination. Yeah, I don't need all that fancy smancy stuff. Oh, okay, all right, that's cool. So maybe you don't. But what are you going to do when we run into something like this? Let me get this set up here. All right, what are you going to run if we do when we get into a 2x1 minus 3x2 equals 6? 3x1 minus 2x2 plus 4x3 equals 0. And 6x1 negative x2 negative 3x3 equals 7. What are you going to do there? How are you going to use your elimination method, your algebraic ways to solve something like that? You know what? You can do it, but it's hard, extremely hard. The methods that I'm teaching you are going to very, very, very quickly and easily work these types of problems. Now, I told you that I'm going to teach you a way that makes it easier, and you may be telling me, Dr. Darbro, so far, it's not easier. It's just not. And you know what? It's not, but it's getting ready to get easier. Let me see where I want to go from here. Well, I'll tell you where. Let's go. Let's just go where I want to go. Enter your new best friend. Well, not really. Wish I knew why that happened. Augmented matrices. An augmented matrix is a accumulation, if you will, of all of your coefficients of the problem in a certain ordered form, ordered fashion. That's going to do wonders in working problems for us. So let's revisit the 3x1 plus 2x2 equals negative 2. And then we had 2x1 minus x2 equals negative 6. The augmented matrix for this is going to include all the coefficients. So if you think of all of them, kind of ignore this equal sign right now, okay? Just look at all of them and kind of ignore the x1 and the x2. What do we have? We have something with 2 rows, and we have something with 1, 2, 3 columns. The augmented matrix for this problem would look like the following. With no distinction between what goes with the variables and what goes, well, there is a distinction because these are placed over here kind of to the right, like these two negative 6, but there's no distinction between, before we had everything with a variable in one matrix and everything without a variable in another. Now we just throw it all into one matrix. Okay? So guys, this is the augmented matrix. Now the simple way of solving using the augmented matrix is graphing calculator. So what we're going to want to do is we're going to go into the calculator, do some stuff that I'm going to teach you, and ultimately we're going to come out with a solution that I'll explain to you what it means, okay? So guys, we're going to go into our calculator and put in the augmented matrix, and I'm just going to go in here and I'm going to choose it to be the first one. So I'm changing what I call the coefficient matrix to the augmented matrix, which is a 2 by 3. So that's still the same. That's still the same. I need a -2 there. Still the same. Still the same. But I need a -6 right there. Okay. Now I've entered that, so I want to go second function quit. I'm going to clear it out because I always like to start with the blank home screen. I'm going to go back into matrix, but I'm going to do something different this time because I'm working it a different way. I'm working it the easy way. So I go over to math, and guys, I'm going to scroll all the way down. It's probably easier just to scroll up because it'll let me start at the bottom. And the command we need is closer to the bottom than it is the top. And I'm going to go to RREF. I've heard some students call it row ref. It's not. It's reduced row echelon form. Ignore that. It's not relevant. But that's what it is. Like I said, it is relevant, but I'm not going to hold you responsible for knowing the technical name of what we're doing. Now, this is an entry-level course. So I'm going to go RREF. I'm going to go get the augmented matrix that I just created. And when I hit this, I get my answer. For the most part, when you see the one, and let me get over to where I can write. So I've got 1, 0, 0, 1, -2, 2. Now let me explain to you. I wrote that down. Let me go over here and explain to you what that's telling us. That's telling us first and foremost, it's the solution. So whatever is in that last column, daggone it, that's really starting to irritate me. The last column is the solution. And what's in the first entry and the second entry, this is just our x1, and this is our x2, or if we're using x's and y's, it would be x's and y's. If we could even we're going to get in a situation where we're going to have maybe a third variable, or which we could call z, then whatever's there would be our solution. But right now, our solution is this. And the reason it is what you're kind of thinking here is you've got your columns x1, x2, and then your number. Because that's, if you go back to where we set this up, that's kind of what we've got. These 3's right here came from the x1's. This 3 and the 2. 3, 2 came from the x1's. This 2 and -1, these things came from these x2's. And these things right here came from our numbers. Our constant without the variable. So I can keep that same theme and think about when x1 is equal to 1. So this right here is telling me that 1x1 plus 0x2 is equal to -2. Well, when all the smoke clears, what's that telling you? That x1's -2. This thing right here is telling me that 0x1's plus 1x2 is equal to 2. Well, 0 times x1 plus 1 times x2, when all the smoke clears, is just telling me that x2 is equal to 2. It's just telling me that my solution is -2, +2. All right, gang. Let's get into a more complicated situation, if I can find one. I brought my book. I know exactly the type of problem that I'm wanting to look for. Um, so, well, wouldn't you know? I can't find it. Yeah, actually I do. All right, so let's say that we've got something like this. Let's say that I want you to solve 3x1 plus 5x2 minus x3 equals negative 7. X1 plus x2 plus x3 is negative 1. And 2x1 plus 11x3 equals 7. All right. Now, if you were to try to do this problem using probably the tools that you came into this class with, that would be extremely difficult. And ultimately what we're trying to do is we're trying to set the foundation by which we can go work application problems with, like a business economics theme to them. So sometimes we run into situations where we have 3 variables. Keep in mind that the number of variables must equal the number of equations. And keep in mind that you've got to have your structure organized here. So guys, what I see here is I've got some kind of wackiness going on here with this last equation. I did that purposely, that my x2 is missing. Before I actually get to a situation where I'm going to put this into an augmented matrix form, I've got to take care of that. So guys, I'm going to rewrite the problem as 3x1 plus 5x2 minus x3 equal negative 7. x1 plus x2 plus x3 equal negative 1. And 2x1 plus 0x2 plus 11x3 equal positive 7. What I'm now going to do is I'm going to create my augmented matrix. 3, 5, negative 1, negative 7, 1, 1, 1, negative 1, and 2, 0, 11, 7. Notice all I did in the augmented matrices is just put the coefficients of the problem in a structure that is organized. I've got 3 variables, x1, x2, x3. I've got 3 equations, the first one, second one, third one. Okay? So life is good. Well, I don't know if it's good or not, but at least it's set up to do this type of problem. Now, gang, what I got to do is I need to go into my calculator, and I'm going to set this up very carefully. I don't want any typos, because typos, just get you frustrated. So I'm going to go in and type in the values. So grab your calculator. Now I'm going to show you a trick here too. I'm going to leave this up here. I'm going to clear this out, but nevertheless I'm going to go into matrix. And I'm just going to use matrix A because it's there. And I see the matrix A in my situation needs to be a 3 by 4. So it's a larger matrix. Got more equations, more unknowns. So I got 3, 5, negative 1, and negative 7, and a bunch of 1s, and a negative 1, and a 2, and a 0, an 11, and a 7. Guys, you cannot work this problem any faster than the way I'm teaching you right now. Second function, quit. Now guys, I just did that RREF for matrix A, the previous line. Now, it's not showing there, but your calculator remembers it. So I can go second function RREF A. Now granted, I've changed the A since I did that, but your calculator's pretty smart. It can figure that out. I can hit enter and you see I get my solution. This 1, 0, 0 just tells me that x1 is equal to negative 2. This second line tells me that x2 is equal to 0. And this third line tells me that x3 is equal to 1. So gang, my solution, I don't care what you say, you can't get this problem solution any easier than I just told you. Our solution to this problem I'm going to write this down so I can from your calculator looks right like this, okay? This part right here tells me what? This is the solution. So guys, I used x1, x2, x3. So x1 is equal to negative 2, x2 is equal to 0, x3 is equal to positive 1. This is equivalent to negative 2, 0, 1 as the solution. Okay? Now, what are you going to do if you run into something that looks like this? So, new problem. Well, 3 variables. 2 equations. No can do. Now, there's things we can do. We can get solutions. We can find the form of the solutions, but in an applied course of this nature, we typically don't get into stuff like that. Okay?